Data preparation. It is considered as most tedious and time-consuming process in data science project. In many projects, it takes more than 50% of the time and efforts. Especially for beginners, data science, data preparation is a nightmare. I mean, they spend a lot of time trying to translate the data or prepare the data as required for the model. Actually, they spend a lot of time on that without much of results. Data preparation is also referred as data manipulation, data wrangling, or data munging, etc. Okay. Python Pandas is a core package, a standard package, industry standard for data preparation. In this session, I'm going to go through 40 useful tricks of Pandas that can make your life easy. Right. Most people struggle because when they learn Pandas, they learn the basics and try to jump into the problems, which is good. But if you master Pandas, learn all the tricks, then I can assure you data preparation can be fun. It's like solving a problem. Right? Once you have the right tools, right techniques, you could easily you can do the data preparation much easier, and I guarantee you that you'll enjoy it. Okay, so in this tutorial, I have collected 40 useful tricks from my 5 years of experience in delivering data science project and teaching people. I broken down into 4 parts, 10 techniques, 10 tricks in each part. Okay, so they are here. So I listed them here. In the first part, in this video, we are looking at extracting data with regular expression, pivot table, cut function, strings, removing outliers by filtering, apply function, set. So these are all the tricks which actually the best way of doing solving a certain data preparation problems. All right, so let's get started. We'll start with the first one, extracting data. Okay, so I have collected few data sets, so it's put it in a Git repository and given the link as a path over here, so it makes our life easy. You can choose any data set as required, so we can do more hands-on. Importing pandas and numpy in case. All right, so the first one is extracting data with regular expression. So I'm going to use, let's say, house price. Let me look into this. Okay, so data is equal to PD, which is pandas, read CSV, and HP cost. Okay, so I usually print the shape of it so that we get to know how many records, how many columns, and also first 5 records, so that we know what is this data set. It's importing from Git repository, may take a moment. Okay, we got it. So it seems only 10 columns and 13,000 records. All right, and it's a house price data set. So it's a city of Bangalore, as you can see the location, or Bangalore city location. I live in Bangalore. Area type, which talks about plot area, build-up area. Availability is ready to move or sometime in the future. Location, size, talking about bedrooms. Society, total square feet, bathrooms, number of bathrooms, and balconies. And this field is interesting. It says other costs. So essentially there are some costs. I guess this is customization, so they can actually, you can add more customization to what builder provides, so that might add a bit cost. And it is registration cost. I think this is miscellaneous, and you can see that this field is a bit tricky because you have text, you have numbers, and actually we need the numbers because when you say the total cost of the acquisition of this apartment or the house, you need to add up this extra cost along with the price, right? So this becomes a challenge. So how do you extract these things, these costs? They're actually in lakhs, which is 100,000. Lakhs in India is 100,000, right? And it's 2 lakhs INR. Even this is also, I guess, in lakhs, right? Not mentioned, but yeah, it should be in lakhs. There are different items. Even there are sometimes more than 4. Is it 4? Yeah, 4, 3, 2, and different things, right? regular expressions can really help us in this. So what is regular expression? It's a simple pattern with alphabets and special characters, which is used to match a string, a substring in a string, and to find them, match them, search them, extract them. So it's really handy. You can write down certain patterns, and then you can match it to the string. All right, so let's do that. So it's more easier understanding while doing. Let me get this column, which is other costs. I'm going to only take the one. Okay, the first one. So you can see that customization is 2 lakhs, registration cost is 1.76 lakhs, and miscellaneous cost is 3.7 lakhs. All right. What I'm going to do, I'll just type in regular expression. I normally don't remember all of these. But it's quite simple. This seems I already clicked this one before. Okay, so this is a cheat sheet. So essentially we have a bunch of special characters, special characters with alphabetic. These are quantifiers. Regular expression is a big topic, so my purpose is not that. I have another video for that. You can search for it. So this /d represents 1 digit. So if you simply say str, which stands for string, and then you say find all as one of the functions of regular expression, I'll say /d. You could see that it literally took every single digit, 201767. You can see 201767. So this is not what I wanted. I want the number intact. I want the entire number with decimals. I can use by using the quantifier plus, which is 1 or more of the digits. I put a dot because that's a decimal, which again I put this one. And you can see that we managed to extract the numbers intact. Customization is 2 lakhs, and even the L is not taken, so it's really good. I'm going to create a quick column which it says order cost, and what do we call that? List. It's a list, so let us call as list. Okay, and then let me look into it. So yeah, so as you can see, we got the numbers we want. All right, so now the work is to combine these numbers and add it to the price and probably call it as total cost. Okay, let's do that. How do you do it? So you need a for loop for that. For I'm going to use iterator in data iter rows. This is one of the best practice iteration in the data frame. All right, so the I contains the record index, all right, and the row contains the entire data, the data of that record. Okay, so I'm going to say data dot loc, and I'm going to give I as the index number, and I'm going to define a new column called, let's simply call it as total cost. Okay, now I'm going to add price of each and every record. So it's a iterator, so I can simply say row dot price. That automatically gets the price. Plus now we have a challenge, so we need to combine these 3 things, right? 3 or whatever, how many ever it is, 3 or 4 or 2 or whatever, and let me first see. I guess they are not actually numbers, they should be strings because it's coming from regular expression. So data dot other cost list, and let me take the first one. Or see, we have a single quotes which basically says they are strings. So how do you go through it? Let's run a inline for loop. So I'm going to say x for x in row dot other costs list. So it's going to go and pick each one of it and then give it to the x, and here I'm going to convert it into a float because I want a number, not a string, and then I can sum this up together. using a sum function. This should work. If anything is wrong, we'll get to know. I'm going to run this one. It takes a time a bit because it's done. So it's about 13,000 records. So it's good. Now let's look into it. Oh, I'm surprised I didn't get any error. Normally it gets, oh, okay, great. So as you can see, so if you simply add this 2 plus 1.6, 3.76, okay, 7 point something. So yeah, it seems okay. This is a little easier. 2.4, 5.4 is 7.8. So 127.8. So yeah, great. So we done it. So this, if you don't use regular expression, you have to do a lot of coding, and yet you may not be sure if something goes wrong somewhere. Maybe there's a space here, there's another thing. If you're trying to split it and do it, it becomes tough, and you cannot write something foolproof easily as I have done. How many lines you have written? 2 lines? Yeah, roughly 2-3 lines, and we are done. So that's the power of regular expression. I suggest you to explore it, and it's really handy when your numerical data is hidden or mixed up with the text. It helps you to extract. Okay, let's move on to the next one. Pandas pivot table. If you are experienced in Excel or any spreadsheet or even Tableau and other things, it's quite easy in Excel to actually or any spreadsheet, even Google spreadsheet for example, to create a pivot table with the columns and the rows, and then you can actually see the numbers aggregated. That's really easy. Pandas provides actually similar kind of feature, and it's actually easy as well if you know how to use it. So let's use another data set. Let me see. Yeah, obviously we can use superstore orders because yeah, we can do something with that. So I'm going to copy paste this 3 lines of code because that's going to be the same. I'm going to overwrite the data. You don't need a different, also consumes memory, so let's overwrite it. Okay, so this is a superstore orders. Let me see how many actually got it from GitHub. So it took a moment. It's about nearly 10,000 records and 21 columns, as you can see, order ID, shipment date, and many other things. Okay, great. I'm going to right away do the pivot. I'm going to say pivot table. What is this? So I want to see region wise sales and category on the column. So just say columns is equal to, I can give multiple columns. Let's start with one category. Spelling correct, and yeah, okay, not bad. Comma index is equal to, I'll give region. I think it's region. Okay, and then I'm going to say the values is, I want to say the sales. I think it's sales. Okay, sales, and okay, aggregation function. Aggregation function is AGG, and you don't have to remember, just type tab, or if you're using an IDE like PyCharm, it automatically populates for you, auto code completion. Of course we are summing it up. So it's pretty straightforward. The data frame, which is stored in data, pivot table, columns is category, and just run it. You can see that already. So columns is category, so these are columns, which is category. So it will be nice if I have region over here and category over here. Yeah, this looks better. Okay, so I have region in columns, the east, west, south, and central US. So and then the furniture, office supplies, and technology are category, and these are the numbers. So these are the entire sales of furniture in central region, and so on and so forth. Okay, so that's actually quite straightforward. Great. So I mean, you can also give other things. For example, I want to also look into profits along with the sales. You can simply mention as a list. I can say okay, let me leave that, copy, make another copy here, and then I can just okay, so I'm gonna put profit here. So normally we look at the sales and profit side by side. So here we go. So this is your profit. Oh, okay, that's interesting. I gave sales and profit. It has given me profit and sales. Okay, or maybe it's taking alphabetical. All right, so the profit. Oh, this unfortunately we have a loss in furniture in central region. Other regions are fine, but central we have a loss. And yeah, so if you want to make this okay, if you want to make this more readable, right, you want to see what is the high and low, you can put some styling. Any data frame you can put styling. Just simply style, and you can say background. It's not coming. Background color, and you can give a C map, color map themes. Okay, and is equal to, let me say, cool warm. There are many things you can say, green, blue, and etc. I don't know if this works. There is a problem with that. It is background. I just search for it. Gradient, right? So you don't have to remember all of this. If you use it frequently, then you will anyway. Gradient. Yeah, see. So essentially blue are the lower values, red are the higher values. Just by looking at it, I can already see that the profit of different categories, technology is the one which is profitable in all the regions except the west region, in which the office supply is more profitable. When it comes to sales, technology is the highest in all. In fact, here it's almost same with the furniture. So color shading will give you a little better. So this color styling is common for any data frame, so you can use it for here as well. Okay, so that's that easy. I can even put multiple values in columns, for example. So I can actually say category, so I can just add maybe subcategory as well here, comma. I don't know how many subcategories, so it might actually flood my screen now. That's okay. That's not that bad. So see, I can actually look into it and say, you know what, the highest profit you're getting is actually in the west region is actually by selling copiers. So you can see this this number here. Okay, so the west region copiers are actually making the highest profit, and phones are making highest profit in the south. And in fact, copier is the highest profit making in central, east, and west. Okay, the lowest is actually something between this. So this is the lowest. The furnishing in furniture is making a lot of loss. In fact, about minus $3,000. And you can also interpret the same thing in sales. So this is as good as any visual tools, and I really like Python because it's fast and can actually handle millions of records easily. So pivot table. No, sorry.
I didn't catch that.
Okay, I didn't talk to Siri. So that's pivot table. That's our second trick. Let's move on. The third one, Pandas cut method. Cut method can be used to convert a continuous value into a categorical value. All right. So let me see, where can we use it. I'm going to use another data set. Okay. All right, let's take a wine one. So, oh, sorry. I could even type it down. The time it is taking to go. Okay, so I'm going to simply say wine. Let's see what is this wine data set is about. Okay, so it doesn't really import properly because it says CSV. CSV is comma separated value, and you can see that there is no comma separation. This in fact is a semicolon. So I need to specify a delimiter, which is semicolon. Delimiter, sorry. Why it is not autofilling? I'm going to give a semicolon and see if it works. Yeah, okay, good. Cool. So this is actually a data set which talks about the wine quality. I think white wine in this case, and it has fixed acidity. These are all chemical properties. So, and there is a quality given in not continuous, it's more like a discrete values, but that's fine. So and I can actually see how many wines totally. So we have about 4,800, nearly 5,000 wines. And let me look into the quality in more details. Data quality, I'm going to do the value counts. Value counts or count values? Okay, value counts. Okay, so we have about 2,206 rated, like this is a quality 6, right? 9 is the highest one. So we have 5 wines which has a very highest quality, and 2 and 3 are not so good ones. So rather than having this 0 to 10 scale, sorry, I don't know, 1 to 10 scale, okay, I would prefer to have something like, let's say, a bad wine, a good wine, and a premium wine, right? So I can achieve this by using a cut function, right? I can achieve this in many different ways, but cut function gives you much more. Okay, so I'm going to say cut is actually a direct function in the pandas. Cut, I'm going to say quality, and then I have to define the bins. So bins are, so I'm going, so 0 to 5. Okay, 0 to 5, 0, 5, when you 0, 5, so 0 to 5 becomes one category, all right? And then I'm going to say 7 and then 10. So 5 to 7 is one category, and 8, 9, 10 is other category. And I have to give the labels for it here. So labels, as I said before, I'm going to say bad wine and a good wine and a premium wine. Okay, let me just, okay, so I need to store it back to the same data.quality, and let's overriding this. Okay, I rather create another field than overriding, so I'm gonna import it again. Okay, so I'm going to create another field which says, let's say, quality category. Okay, so, and then let's look at it. Let's look at more files. Let's say 10 maybe. More records. Okay, so everything is 6. 6 is actually good, isn't it? So 6 is actually good. So that's good. But I want to see if other numbers can be seen. Okay, here we have some. So 5 become bad because 0 to 5 we have said as a bad here. Okay, and then you have any premium? Yeah, 8, because you know your good ends at 7. 8, 9, 10 becomes premium. Okay, they have premium. So by using cut in a single line, I've converted a discrete or even continuous into a categorical labels. So that's a really useful one. This takes a lot of time if you do it manually, and it could go messy and even get into mistakes. So cut offers a smooth functionality for converting a continuous variables into a categorical variables. Okay. All right. Let's move on. Fourth one, split strings to columns, and I'll just close other windows and expand. Yeah, expand is an option. Split strings to columns. So which one we take? Let's take some reviews, books, authors. Okay, I'll take this reviews, book reviews. Okay. Okay, that's nice. I'll simply change this to book reviews. What happened? Oh, so I think it's an Excel sheet, so it's not CSV. Okay, great. So we have a very small data set, 100 records, and we have 8 columns talking about title of the book, author, reviews, and ratings, and some synopsis, genre, book category, and the price. So let's see. I have author here. So author is just one name. What if I want to make it a first name and last name? I want to divide the name into 2, have its own fields. I can do that by simply, let me say, author dot str dot split and then I can split using any delimiter. So I'm going to split using a space. So wherever you have a space, it gets split. Okay, so you can see that it automatically split, and there is also people with have Shivananda Yoga Vedanta Center. So it's not an author, it's more like a publisher, I guess, or some. Okay, so some ashram. All right, great. So I can restrict the number of splits by using an n value. If I say n is equal to 1, then you will only get one more split. So you can see that Yoga Vedanta Center has become just 1. Previously it was showing us a four elements in a list. So this n really helps us to restrict that. And then I'm going to say expand is equal to true, which will essentially creates 2 columns for you. All right. And I can take the first one is 0, and that gives you the first name. Now what I'm going to do, I'm going to simply say data, and I create a new column called author first name, and I store this to it. Okay, and let me also do the second name, last name, and then I'll just change this to 1. Okay, and then let me look at the data. Here we go. So there are 2 new columns being created with author first name and last name. Very clean. So we are able to split the data into 2 columns. All right. It can be very useful if the data is consistent. For example, see, here we have reviews which has 4.0 out of 5 stars, 3.9 out of 5 stars, and if you observe here, it is 9.6 out of 10 stars. They are not consistent. Some are rated in 10 scale, some are rated in 5 scale, right? You cannot compare things, and it's a very valuable information. Reviews are actually the very important information for your analysis or building any predictive models. For example, if you want to predict a price, reviews are really important. I want to convert everything into a percentage, so scale it up to 100%. Okay, let me give a try. So I can let me create some more empty cells. Okay, and I'm going to use a split like what we have used just now, and try to do some maths to get this reviews, and then str. I'm going to split, same with the space, and then I'm not going to restrict the n because I think it's more structured. 4 out of 5, so you get 1, 2, 3, 4, 5. So 5 elements which will have an index from 0, 1, 2, 3, 4. All right. So, and then say expand is equal to true. If I just run it, what happened? Expand. So we got as we thought, as we have it's basically split it. Now I'm going to take the first one and divide it by, so when you do a splitting string, you get a string, so I have to convert into a float, as type a float. Okay, and I'm going to divide this into the same, but this time I will take this one, okay, the third one. So I'll just change this to 3, and I'm going to store this into a new field called as reviews percentage. Okay, now hopefully it runs. It did actually. Okay, let's look into this. Oh, it doesn't look nice because it's I got it actually. So let me multiply into 100, so then it really looks like a percentage. Okay, great. So let's take a look. 4 out of 5 is 80%, 3.9 out of 5 should be 78%, 9.6 out of 10 is 96%. So now we have created a column which is uniform across all the records, and it is like the scale is being normalized, as well as the data is taken out of this text context and made as a pure number, a float. And you can use this field for your analysis. So split can be very helpful if you use it correctly. I'm going to share this Jupyter file in the description, so you can actually go through it again if you have any doubts. Okay, let's move on. You don't need so many fields. Now I can just delete some of this empty. Okay. All right. So now the next trick is about removing outliers. Well, again, we have many ways of removing outliers. Normally we look into the box plot and then we try to manually filter it out. That's all fine. But you can also do it by using z-value. Z-values from statistics. So z-value is nothing but the value minus mean divided by standard deviation. So it's literally z-value is equal to x minus mu or mean divided by standard deviation. Okay, we don't have to calculate this. If you remember this normal curve histogram, right? So z-values, anything more than 3 or less than minus 3, we consider as outliers. So if the value is more than, so I do not have, okay, let me see if I can draw. I didn't have my stylus as well. Okay, that's too big. Okay, let me just draw it quickly. So if this is your data, let's say it's a normal distribution, something like this. That's okay. Okay, so this is your mean, hoping that it is near to normal. Okay, so the distance from the mean, if it is 1 standard deviation, we call it as z value is equal to 1. Okay, in a similar manner, you can have z value is equal to 2 and z value is equal to 3, and this side it is z value is equal to minus 1, minus 2 and minus 3. The values which fall after this are really less. In fact, if you're a perfectly normal distribution, this will be around 0.3%, and they are considered as outliers, means that they're extreme values, and we usually eliminate the outliers, which is good for the model. Very small percentage of the values, usually around 0.3 to 0.5%, and their presence actually make your model less accurate. Okay, so we normally remove that. So we can use a function from Skippy, a module from Skippy called stats, and stats has z-score. Okay, I'm going to use that. Okay, I need to first of all import a data. So I can use, let's use a simple empty cars, which is a very small data set. PD read CSV. Okay, empty cars. Okay, it's a really small data set. Okay, I don't have to look at the shape of it. So it has car model, mileage, it's about the cars, right? Mileage, number of cylinders, displacement, horsepower, draught, weight, q-sec, which is time taken to reach 1 quarter mile, the quarter second. Q-second is quarter second. VS is a engine shape, and AM is automatic manual, number of gears, and number of carburetors, right? Okay, so I'm going to look into outliers for this. The best way to do that is by just, let's say, stats. Okay, stats dot z-score, is that correct? Yeah. And then I'm going to put data.hp, just one value. So these are all the g-scores of all the records, right? So if you look at how many records we have, I think we have about some around 20 or something. 32, I guess. Yeah, 32. So I have 32 records, and these are actually 32 values. These are all z values, okay? And what I can do, I'm looking for absolute z value. If it's less than -3 or greater than +3, we consider them as a outlier. So I'm going to say absolute value of it, okay? And then I can say if it is less than 3, actually everything is less than 3. That's interesting. I can just make it even less, 2.5 for example. So you see one value is going up, right? And if I pass on this thing to to your data set. So you get all the values except the one which has, I don't know which value is that. Let me find if there's a number missing. Yeah, there's a number missing here. See, the 30. That's the record. This is for one column. I want to do it for the entire data set. Let's say all the numerical fields. Of course, this can be only done for numerical fields. I can do that by the same function, but I'm going to just leave this entire data, not the entire data, because the first column is your string, so I have to remove that. So I'm going to say ILOC, take all the records from first column is removed, the 0 is not taken, so from 1 to like till the end. Okay, and I'll just get it back to 3 itself, because 3 is a standard value for outliers. Okay, and I have to okay, so that is it. I should also do this. Absolute value is less than 3. Okay. I have to say all axis is equal to 1. Yeah, okay. So I'm applying for all the columns, and axis 1 essentially means you're talking about the column. Axis 0 is a row wise operation. Okay, so if you look at it, there should be some values missing. Any value missing? I don't see any value missing. Okay, so sorry, this has to be outside. Okay, I'm going to just put all of these, let's say all axis is equal to 1. Okay, there's a dot over here. Invalid syntax. So did I close this one? This has to be closed here, and then it has to do. Okay, my apologies. So is this working? I have, yeah, one value is missing over here, which is correct. And is there anything else missing? Yeah, I have a 7 missing over here, and then I think that's it. 21, 23. Yeah, so 2 values are eliminated because they're outliers. So this way you can do the entire outlier analysis by using a single statement across all the columns of your data frame in one go. Okay, that's really helpful. That's about removing outliers by filtering by using Z-score. Moving on, trick number 6, handle missing values with dropna. Dropna is function drop not available. So let me just load one of the data sets which has missing values. We have intentionally created a data set empty cars with a lot of missing values. Let's purposely removed values in that so that you have missing values. Okay, so we have some special characters as well in the place of missing values. You can replace them directly by saying replace. I can just give all of this, what is that, dollar symbol, this one, and then you have a star, and then you also have an hyphen. So I'm going to ask, how do you know that you have this? How this data? Normally data sets are big. You can find it by using regular expression, the one we have seen before. We can also do it in another way, in a very simple, basic way, right? What I normally recommend for the beginners is you can just go ahead and just look at the info and look at it. A pretty common sense. The displacement, it should be number, isn't it? Number or maybe a nan. Nan is not a number, it's a missing value, all right? So if you look at it, the displacement is actually read by the pandas read CSV as an object, which means there is some alpha characters or special characters in the column. In similar manner, you see that the weight is also object, qsec, which is quarter mile second, is also object. So which means these three, displacement, weight and qsec, has some special characters, alpha characters, non-numeric characters in some of the rows. Okay, once you figure that out, you could, okay, so once you figure that out, you could simply go ahead and just creating more cells, go ahead and look into them individually. For example, displacement. All right, so I'm going to say sort values and see. So there are two dollar signs. Obviously when you sort it, the non-numerical value either come at the top or the bottom, so it's in the top. If you want to check if there's any other characters at the bottom, you can say ascending is equal to false, and then you get the bottom. In the similar manner, you can also check for a weight. We have question marks, and we can actually make it as a true and check it quickly. And then what was the other one? qsec. Yeah, star and hyphen. So this is actually pretty straightforward way of checking things. Anyone can do it. And of course, if you want to do it in a more better way, obviously we go for regular expression. So I'm going to replace all of this with a nan, np nan. I use it, and I'm using the numpy here, and I'm going to say in place is equal to true, so that the change reflects. Now if you look at my data, so all the special characters are replaced with nan. Right, now if I want to see how many nan values I have, obviously we use is null. Is null will literally give you true or false. If you run it, you see the entire data frame with true or false everywhere. It does not make any sense, and you cannot really read that. So it's better if you simply say dot sum. All the true values are converted to 1 and false to 0. So when you sum it, it literally gives you number of missing values. So you can see that mileage has 1 missing value, displacement has 9 missing value, HP has 2, draught has 1, and qsec has 14 missing values. The next step you do, how to eliminate them. All right, well, of course we have methods to basically what calls imputation. We actually replace them with a forward filling or backward filling or mean filling, or we can go for even predictive imputation by running a machine learning algorithm to predict the missing values. But dropna simply drops the records. Okay, sometimes we drop the records if there are too many missing values. They are not really used for us. If you forward fill, backward fill, it actually makes the model more bad. So dropna, when you say data.dropna, you can see that there are many records which has been dropped. You can see it's literally become really small, right? A lot of records, you can see the index number, a lot of records are dropped, right? But I don't want to drop all. Okay, I want to drop only when you have many values missing. How do you do that? By default, there is a function, there is a parameter called how. By default, it is set as any, means that any of the value in the record, any of the column value is missing, the entire record is dropped. We can change it to also something called as all, which means if all the values are missing, then only it will drop. Well, that's actually not really useful, because if all the values are missing, then that record is anyway useless. You can always put this command, and the usual problems we face is not that all values are missing, some values are missing. For that, we have something called a threshold. All right. So I can specify a number saying, let's say how many records we have here, how many columns we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12. Let's say I'm gonna say that if I have 10 values, then I would retain the record. So I can simply put a 10 here and run it. So now you can see now there are quite some numbers missing here, but you do also have records which has 2 values missing. See this one, the 14th one. We have nan here, we also have nan here, but still it is not dropped, because we said if you have 10 valid values out of 12, we have 10, the record is retained. So threshold really helps you to fine-tune your strategy of how much, how many records you want to, how many records how many columns have value which you want to retain. So basically this is nice. We can also do it on a column wise. Let's say we know that QSEC has a lot of values missing. All right, so I'm going to say dropna, okay, and then I say threshold is equal to so rather than giving a number, which you can do obviously for columns, it might actually make some sense, but rows there are many, so it does not make much sense. We give a percentage. All right, so if you say len of a data, you get number of records. I got 32 records. I'm going to say 80% of the records. If you have, then I can simply say 0.8, so 26.5, let's say 0.6. So if you have 60%, more than 60% data, then you retain the column, otherwise you don't retain. Okay, I'm going to put this as len data, and then I say 0.6. So let me see. Oh, I have to say axis is equal to 1 because this is a column operation we are doing now. Okay, you can see that the QSEC column is dropped, which means QSEC has even less than 60% of the valid data. All right, so if I make it 70%, no, if I make it 50%, it might come. So it came. So if you put 60%, it is not coming. So by using the threshold, both row wise and column wise, we can fine tune and eliminate a major chunk of records before even going into the imputation. Right, it's really important. You can't just keep on imputing if a lot of data is missing and filling with some numbers, forward backward filling. It's not very effective for your model. Right, first of all, you have to eliminate the records which a lot of values are missing, either column or the row, based on your business analysis. Then we go for the imputation. Okay, that's how we use dropna. Moving on, now we have pandas apply function. Apply function is pretty straightforward, very useful function. It applies a function, a method, to the entire data frame. Okay. For example, I'm going to read import a data for apply function. Let's talk about the house price itself. House price Bangalore. Let me print the shape and then the first 5 records. Okay, we have 13,000 records, and we have area type, location, the same data we have seen before. Okay, and so I'm going to use pandas apply to apply the label encoder. So we have multiple categorical columns over here: area type, location, society, and this can be also considered, but let me just take only 3 of it. Okay, so I'm going to say data LOC, all the records, and then I'm going to say area type, location, and society. Okay, did we get this 3? All right, so I'm going to label encode all of these 3 in one go. For that, I need to first of all import label encoder, which is in sklearn preprocessing import label encoder. Okay, and that's good enough. Label encoder. Here I'm going to say dot apply. All right, and then I literally initiate the object here and say fit and transform. That's all. Okay, transform. What's the problem? Argument must be a string occurred on index location. Data apply. I don't see any mistake. Oh, I might have a missing value. Yes, we have a missing values over here. So let me fill all the missing value with some kind of forward or backward filling. So I'm going to say fill NA. I'll say method is equal to ffill or forward filling. Okay, and then I'm going to say in place is equal to true, which will make the change, and then run this one. Okay, so now you can see that all of these are converted into the numbers, and I can literally reassign it back to it. I can just say that this is equal to this, and then we are done. So in one go we managed to apply, see, your type, your location and society has all changed. Well, of course, if you're doing a production project where you have to also transform the new data coming in, then you have to go for label encoder as a list. So we need to retain the label encoding labels, like what string is mapped to what label, because you need to do it like when the new data comes in, you have to use the same one. But for now, if you're doing a quick modeling, this kind of things are pretty straightforward. We can use apply function for all these kind of things. What it does, it takes a function, in this case a label encoder, and it applies for every single record. All right, and in this case it actually taken 3 different columns and it applies row wise. This is really helpful when you're applying a complex computation or any computation across all the elements in your data frame. Okay, so that's your apply. I also have another video on apply, a more detailed one. You can search for it. The apply is really helpful. It solves many problems in data preparation. 3 more tricks to go, and this one is quite simple. Pandas set option. I often have difficulty to see all the columns, right? Because it only shows certain columns and shows dots. For example, let's import breast cancer data set. Data PD read CSV breast cancer. Okay, and I'm going to print the shape and then head. Okay, so there are 569 records and 31 columns. When you look at it, you don't see 31 columns. See, there is like dot dot dot, means that there are many. But I don't want that. I want to see the columns, right? I'm sure many of the beginners would have faced this problem, and you can see the column by looking at info and other things. But I want to see in this view that is possible by changing the default value of maximum rows, right? That can be done by simply saying PD display set option, sorry, set option, and then I'm going to say display dot max columns, comma, I'm going to set it to 50 now. All right, so the standard, I think default is around 25. I'm going to set it as 50. Hopefully, yeah, okay, it worked. Now I'm going to look into the head function. So now you see that there is, like, because there are only 31 columns we have in the data set and I have set to 50, I'm able to see all the columns. Sometimes it's handy to see all the columns, given that they are not like too many. So if it is 30, 40, 50, you can still see all the columns. And this function helps you to change the default value. It's not the only function. Set option has many functions to change the default values. You can just go ahead and say set option, and then you can just press shift tab 2 times, and then you can explore. There are many options you can change, and this comes really handy. Okay, you can change the column space, default precisions of float, encoding by default is UTF-8, but you can change it to Latin or other things as a default. You can essentially change all the set parameters, the default parameters of pandas. So this set option method is very helpful. Okay, I suggest you to explore further. In this trick, I just showed you how to change the maximum columns, which helps you to see more columns at one go. All right, so trick number 9, extracting month and year as a separate columns from Pandas DataFrame. The first question, why do you need that? Well, so let's take the data which we have just seen, the Superstore orders data, PD read underscore CSV, and I say Superstore orders data. Always look into the shape. So you should know the breadth and width of your data before doing anything. So this is your about 10,000 records, 21 columns, as you can see. All right, and I want to if you look at the date here, there are order date and shipment dates. Let me first look into if these dates were actually imported as dates, because many a time it automatically does not recognize it as a date. So let me take the first one. See, it has imported as a string. The first thing you have to do is to import them as a date. You can do that by simply saying parse dates in your read CSV. Date parse, I think it's parse dates. It's not autofilling for whatsoever reason. Let me just give two of these, order date and then ship date. Okay, no errors, so that's fine. Now we can see that the date was actually taken as a date. Okay, now if you simply put month here, it gives you the month, which is supposed to be 11 in this case, because I can see 11. So if I simply say month, it gives me 11. If I say year, what was it? It was 2017. All right, so I'm gonna write a small we can even use apply for this, and inline function lambda. So I can say something like data, let me give something order month, or order year, maybe let's start with year, is equal to data data dot order date dot apply. Okay, and then here I'm going to use a lambda, because apply only takes functions. So lambda is an inline function x, and then I'm going to say x dot month, sorry, year. Okay, so what I have done, I have taken the value here, individual value, because apply goes row by row, so it takes one row, gives it to the lambda function. The lambda function returns the year, and the year is being stored in the order year. I'm going to do the same thing for month as well. Here I'll say month. If there is no mistakes, this should run and we should be able to, okay, there was no mistakes. So you can see that there's a two columns created over here. Essentially it has extracted the year and the month from the order date. All right, great. So obvious question, why it is useful? Well, it's really useful because you can, for example, you can use that directly as a call as a variable in your machine learning modeling, which you can do. Even for, let's say, pivoting, we have seen the pivot table before. So pivot table. Okay, let me copy that pivot table from above. I don't have to type. Type it, it's too far. So I'm going to say pivot table. What do you want to pivot? I'm say columns. Columns is I'm going to say region or year. So year, order year is going to be your column, and then the rows or index is your, let's say, sales. So I'm going to say sales on a yearly let's say it's a category. Let me just don't give index at all. So I'm going to give values is equal to sales. All right, and then obviously I'm going to give an aggregate function as sum. Let's see what happens. See, so it's quite easy to find out yearly sales. So I have 2015, your sales was around $484,000, and this was actually 470, and there's $609,000, and this is $733,000. I can then add some more things, like let's say I'm going to add index and say category. So I want to also look at the category. Now you see that a category wise sales on a different years. So extracting the year and month becomes very handy, not only for machine learning as a variable, but also for looking at the data, exploring the data, analyzing the data. Okay, so that's a quick trick to get this this month and year from the day. That's quite straightforward. The last one for this video is a percentage change. So okay, luckily we have the same, this one. I'm going to copy that. And the percentage change function will give you change of percentage. That's actually a pandas function. So I'm going to say percentage change. Okay, I forgot the function name. So let me search for it. Pandas percentage change. PCT change. Okay. Change. Okay. Now you can see, okay, so this actually taken the row wise, which is not what I intend to do, because that does not make any sense at all. So I'm going to say axis is equal to 1. I want to say year wise. Now we can see that from 2015, 2015 the starting date, 16, it will be better if I multiply with 100, so that will be nice percentage. Okay. From 2015 to 2016, you can see that furniture business has grown up by 8.4%. From 16 to 17, the sales has grown up by 16.6%, and then 2018, 8.2%. Office supply, the 2015-2016, there was a dip. So there was actually a dip in the sales, about 9.5%. And then there's 34% increase, 33% increase. Cumulative is actually more than 60-70%. So you can see that. And if you can simply change, or you can add one more thing over here, maybe profit, that makes sense. Okay, so I can see, yeah, so I need to do it separately because I'm using the change function here. Okay, so profit wise, 2016 we made a huge loss in furniture, about 44% loss when compared to the previous year. And then we have made 130% profit, and then I don't know, furniture something wrong, it's going up and down. Office supply is more steady, 11% increase, 13% increase, and 13% increase, so it's going up. Technology from 2015-16 has a huge jump, 55%, and etc. So this percentage change really helps you to analyze the, not the absolute value, but the change in the percentage, so which is very helpful for your exploratory data analysis. Okay, so that is all for this video, and I have 3 more parts I'm going to record in some other day. I hope it is helpful, and I suggest all of the tricks you have to practice in many different data frames. If you find this video helpful, if you like this video, I will request you to subscribe and click the notification button, so that when I upload another video, you'll get a notification alert. Also, if you have other questions regarding data science, data preparation, anything you want me to make a video which is not available, or you find it difficult to understand, please let me know in the comments. I will look into the comments and take the inputs and get them in my pipeline and do it when I do it. Thank you. Have a good day.